All right, today we are moving on to the rational numbers system. So far this year we've talked mostly about integers, and we've kind of added on to what you've learned in 1st through 6th grade. We added the negative numbers, but now we're going to add another group of numbers called the rational numbers. So if you remember at the beginning of the year we talked about number groups, and we started with the natural numbers, which were just things like 1, 2, 3, those numbers that you use when you first start doing math. And then the next number group was a little bit bigger, and those were called whole numbers. And all it did was take all the natural numbers and then it added 0. So it just added one more number. And then from there, we added another circle around the outside. And this one we called the integers. And the integers included the natural and the whole numbers, and that's why the circle includes them, but it also added in negative numbers, so things like -1, -2, -53, and so on and so on. Now we're going to add one more group of numbers, and it's called the rational numbers. And again, it actually goes around the outside of the circles that we've done so far, and we call these ones rational. And the way we define a rational number, right here on the right-hand side, it says a rational number is any number that can be written as an integer over an integer. So it's any number that can be written as an integer over an integer. And I'll show you what that means right down here. So it can be written in two different forms. And the first one is the way we already defined it, as an integer over an integer. Or in other words, it can be written as a fraction. And on top of our fraction, we have an integer. And on the bottom of our fraction, we have an integer. And that's what we call a rational number. A few examples of that. So an integer over an integer, all we need to know is something on top like -1 over 15 is an example, or 53 over -7 is another rational number. The only thing that we have to keep in mind when we're writing them as fractions is that the denominator, the bottom, can never be 0. So our bottom number can never be 0. It doesn't exist. We can't divide anything by 0. So if we have something like 17 over 0, that's not only is that not a rational number, that's a number that doesn't exist. There's no such thing. So before we move on to the second form of rational numbers, just a quick review of fractions, of what they look like, and a few things. We call the top number the numerator, and I'm going to go fast because this is something you've spent a lot of years learning about. On top we have the numerator, on the bottom we call that the denominator, in case you've forgotten. And really what that numerator represents, what that number on top represents is how many parts we have. So it represents how many parts, and on the bottom, our denominator represents how many parts our number is broken into. So how many parts make a whole. So our top is how many parts we have. Maybe we should add that to it. How many parts we have. And on the bottom is how many parts it takes to make one whole number. And the most important part about a rational number, about these fractions, is this fraction bar right here. And that fraction bar, yes, that makes our number fractions. And for some reason that scares a lot of you people. But that fraction bar, that means divide. That fraction bar means we divide the top number by the bottom number, and we're going to use that a little bit later. So back to our rational numbers. The first form we can write it in is a fraction. The second form we can write it in is we can write it as a decimal, which really all we're doing is we're taking our fraction and we're converting it to a decimal, which we've practiced a lot already this year. Now that decimal has to have a couple special properties. It must either be what we call a terminating decimal, So it either must be a terminating, meaning the decimal ends, something like 2.75 or negative 3.4. The decimal, the numbers after the decimals actually end. They stop. That's one form of a rational number. The other one is if after the decimal, if our numbers repeat. Or in other words, if we can write it as a bar notation. So something like 1.3 with a bar over it. That 3 repeats forever. That can also be a rational number. Or something like 3.725, and maybe the 725, those repeat over and over and over again. So those are the two ways we write rational numbers. You've practiced a lot this year going back and forth between the two of them, how to go one to the other. As just a quick review on how to do that, if we turn our calculator on and I turn the fraction button and I do 1 over 4, if I want to turn that into a decimal, I use my best friend button, which is right here. It's the button with the 2 arrows right above enter, and if I push that and then hit enter, it's going to actually change it to a decimal for me. So it tells me that 1/4 is the same thing as 0.25. And we can go the other way around. I can say 0.25. I want to turn that into a fraction, and when I hit enter, it'll actually turn that into a fraction for me. All right, so that's about as much review as you're going to get on fractions and rational numbers. Few things that I need you to know about them really is just adding, subtracting, multiplying, and dividing rational numbers. You've done this a lot. Last year you had to do it without a calculator. This year it gets a little bit more interesting because we're going to actually have negative fractions and negative decimals. But you get a calculator. So step 1, if you need to add, subtract, multiply, or divide a rational, step 1 says to put it in your calculator. That's it. That's all I want you to do this year. We're going to put them in our calculator, and we're going to use that best friend button to convert from one to the other or to simplify. Okay? So whenever you see addition, subtraction, multiply, divide, get your calculator out, let it do the work for you. You showed us last year that you know how to do that already. You don't have to prove that to me again. Number 2, the only thing that we want to be careful of is we want to make sure that the screen on the calculator looks like our problem. It looks like our paper. So when we put it in the calculator, we want to make sure that it looks the same as it looks on our paper. That way we have everything in the right place. And we'll look at a few examples here. So together we're going to do 1, 2, 3, and 4. Number 1 says 5/8 plus negative 6 and 9/12. So I'm going to get my calculator and I'm going to type in 5/8. Oh, let's start over. Now I'm going to type in 5/8. So 5 on top, 8 on the bottom, and I'm going to make sure that I push over so that I'm not in my denominator anymore. And then it says to plus, and it has a parenthesis here. I'm going to do it exactly like it tells me to. It has a plus parenthesis, negative 6. That's not what we wanted. Negative 6. Remember, if you're doing a mixed number, we need the second fraction button. So we have negative 6 out in front, and then our fraction is 9/12. And then we're going to have a closed parenthesis. And when I hit enter, it tells me that when I add those two numbers together, my answer is negative 49/8. So we're just going to put that down, negative 49/8, and let the calculator do the work, and we're done. If I want to double check my screen and make sure it looks like the problem, I have my 5/8 plus a negative out in front, the 6 and the 9/12. Everything's where it should be, so I'm confident that that's my answer. Number 2, again, we're just going to make sure it looks like it looks in the problem. I have negative 2/3 times 2 and 5/8. So I'm going to put a negative, and I'm going to hit my fraction button, 2 on top, 3 on bottom, and I push the right arrow to get next to it, times 2, and it's a mixed number, so I need to use my second fraction button, 5 on top, 8 on the bottom, and when I hit enter, it tells me that my answer is negative 7/4. And again, I'm going to look at my screen and make sure that it looks the same as my problem does right here. And they do look the same. So my answer is negative 7/4. Okay? Now I know traditionally you've been taught to be scared of fractions, that they're scary, that they're hard. Really, guys, a fraction, it's just another number. It's just like if there was a 7 in front. If this was negative 7 times 4. We're doing the exact same thing, but this time we're just using fractions. Our numbers look a little bit different. Instead of being whole numbers, they're parts of numbers. And that makes the math do some funny things. And we'll talk about that more another day, but we're going to move on to number 3. So I have 5/16 divided by a negative 1 3/8. Now this one I want to be really careful when I put it in my calculator because on top I have 5/16 and on the bottom I have negative 1 3/8. So it looks like I have a fraction inside a fraction. So when I hit my fraction button on top, I'm going to highlight the top first, and I'm going to hit my fraction button again because inside my fraction I want another fraction. So now I'm going to move to the bottom to my denominator, and I need to put in a negative 1, and then I need to put in my fraction part. So I'm going to do second and the fraction button, and I've got negative 1 3/8. So I'm going to look at my problem, 5/16 on top, negative 1 3/8 on the bottom. It looks just like it looks on the paper. I'm dividing, so I'm going to hit enter, and it tells me that my answer is negative 5/22, negative 5/22. So negative 5/22. And because my pictures look the same, I'm pretty confident that that's the right answer. Okay. Now moving on to rationals in our other form, in our decimals. Again, they're decimals. They look a little bit different, but that's okay with us. We're just putting them in our calculator. We're going to let it sort through all the math for us this year. So number 4, negative 1.75, negative 1.75, minus, I want it to match my picture here, 3.928. So negative 1.75 minus 3.928. And when I hit enter, it tells me negative 5.678 is my answer. And because my picture looks the same, and in adding and subtracting rationals, we're going to trust our calculator. There's a lot of things we're not going to trust it to do, but this kind of math we feel pretty good about. So go ahead, pause the video. I know this right here says try together. That's a typo on my part. What I would like you to do is pause the video where you're at, and I want you to try these problems on your own. When you're finished, bring it up to me. I just want to double check, make sure that you're doing the work correctly, and then we'll get you the practice for the day.